So now we're going to be graphing the function g of x equals the absolute value of x plus 2. Notice those bars around the x. That means that whatever number x is, we have to take the absolute value of that number and then add 2. So we're going to graph this function by finding and plotting ordered pair solutions. We're going to take a bunch of different numbers for x, calculate g of each one of those numbers to get the y that goes with it, plot the points, and see what kind of pattern they fall into. Ready? When x is 1, the y that goes with that would be g of 1. So it would be the absolute value of 1, and remember the absolute value of a positive number is just that number. So 1 plus 2 equals 3. That gives us the point on the graph 1, 3. Then when x is 2, the absolute value of 2 plus 2 is 4. We get the point 2, 4. When x is 3, we get the absolute value of 3 plus 2, which is 5. So there's the point 3, 5. When x is 4, the absolute value of 4 plus 2 is 6. So there's the point 4, 6. And remember, we don't want to just focus on positive x's. We want to try some negative x's and also 0 so we get the complete picture. So if x is 0, the absolute value of 0 would just be 0, plus 2 would be 2. So there's the point 0, 2. If x is negative 1, we take the absolute value of negative 1, which is positive 1, plus 2, which gives us 3. So there's the point negative 1, 3. If x is negative 2, the absolute value of negative 2 would be 2. That 2 plus the other 2 would be 4. So there's the point negative 2, 4. If x is negative 3, the absolute value of negative 3 is 3. 3 plus 2 is 5. We get a point at negative 3, 5. If x is negative 4, the absolute value of negative 4 is 4. Plus 2 is 6. There's our point at negative 4, 6. Now, do you see how these points are lining up? If we wanted to just draw something that went through all of those points, that's what it would look like. It would be this sort of V-shaped graph, coming down and then turning the corner and coming back up. So, hint, when you have a function that involves the absolute value of x, or the absolute value of something related to x, the graph is usually going to have a sort of a V shape like this, where it turns a sharp corner. Okay, one more example. Let's graph this function. H of x equals the square root of x plus 3. If x is 1, if we put 1 in place of x, so we're calculating h of 1, that would be the square root of 1 plus 3. Now 1 plus 3 would be 4, and then the square root of 4 would be 2. So we have a point where x is 1, y is 2. If x is 2, 2 plus 3 is 5 under the square root sign, and then the square root of 5, well, it doesn't come out to be a nice whole number. My calculator tells me that the square root of 5 is 2.236067977, and really it keeps on going after that. The calculator didn't have room to show me the whole thing because, well, really the digits just keep on going forever. But as far as finding a point on the graph, it's close enough to say, well, it's about 2.2. So when x is 2, y is approximately 2.2, a little past 2. When x is 3, we plug in 3 for x, we get the square root of 6, which is approximately 2.4. When x is 4, we get the square root of 4 plus 3, the square root of 7, which is approximately 2.6. Let's go back the other way. When x is 0, we get the square root of 3, which is about 1.7. When x is negative 1, we get the square root of negative 1 plus 3, the square root of 2, which is approximately 1.4. When x is -2, -2 plus 3 would be 1 under the square root sign, and then the square root of 1 is just 1. So that gives us a point at -2, 1. If x is -3, if we put -3 in for x, -3 plus 3 would be 0. The square root of 0 is 0, and that gives us a point there at -3, 0. And if we try putting anything past -3, like -4, well, -4 plus 3 would be -1. So we're looking at the square root of -1, but there is no such real number. If you try asking your calculator for the square root of -1, it'll probably give you an error message. So we can't show x's less than -3 on the graph. Once we get past -3, we got to stop there. There will not be any points on the graph with an x-coordinate that's any less than -3. So now that we have all these points, let's connect the dots. Let's draw something that goes through them. I started right here at -3. I didn't put anything over here. And then I just went on over like this. And so this sort of curved line here is the graph of the function h of x equals the square root of x plus 3. So if you're wondering what the general pattern here is, when you're graphing the square root of something, the square root of x or the square root of something involving x, you often get a graph that looks sort of like this. And what is this shape? Well, if you started with a parabola, like the graph of when we looked at x squared minus 4, that kind of thing, but then you turn it sideways, so it opens to the right, and then you just take the top half of that parabola. That's basically the shape that we were looking at for the graph of a function like this.